Welcome to Resilient Cyber Show. My name is Chris Hughes, and today we're joined by Varun Badhwar. Varun, thanks for being here.
Chris, thanks for having me on a Monday after Thanksgiving.
Yeah, definitely. I've been wanting to have this chat for a little while, so I'm glad I was able to pin you down and get some of your time here. But for folks that haven't, been following you recently or know what you've been up to in the past, do you want to tell us a bit about your background?
Happy to. So I've been a company builder since 2010. Prior to that, I was a practitioner at Salesforce.com in the cybersecurity space. I was fortunate enough to get into cloud security back in 2006, before it was top of mind for most companies. And really 4 years into that, I realized there was a lot of information I knew, a lot around the technology stack that I knew that others could benefit from. I started kind of creating companies. The first one was a company called CipherCloud in the SaaS security space, focused around encryption, data protection for Salesforce and other apps. That market came to be known kind of obviously broadly as the CASB space. And then in 2015, I kind of saw this massive shift, which was even bigger than the SaaS shift around cloud infrastructure. And, the paradigms for security were going to change again, right? There was no network, there was no perimeter, like your identity was shifting, everything was shifting to the cloud. And so, created a company called Redlock, which eventually became the category creator behind cloud security posture management. We kind of built that out from inception to an exit with Palo Alto Networks towards the end of 2018. That was a 3-year journey, after which I spent 3 years building Prisma Cloud for Palo Alto Networks. And it was in that journey and during that journey, especially after SolarWinds happened, that a lot of questions were being asked by our board, by our executives around software supply chain security. And in just digging through that, just with trying to solve this for my own team, I came to the realization this was a really hard problem, an unsolved problem at scale, and kind of led to the founding of Endor Labs, which is what we've been working on for the last 1 year.
Yeah, it's really exciting stuff. You've seen to, be able to tell where the industry is going, focus on that problem, and then, be successful in building a solution to that. So that's really cool. I wanted to ask you, before diving into the software supply chain stuff a little bit, what kind of led to you being able to take that first leap of saying, hey, I'm going to go out on my own and try to make a run of this? Like a lot of people are scared to do something like that. So what led you to do that?
Yeah, Chris, frankly, I was kind of 4 years into Salesforce as a security practitioner. Life was great, but you can call it a first world problem. I was just bored. And when I was bored, I said, okay, let me take my GMAT, let me go apply to business school. Back in 2010, that's the way to kind of do a career switch. And just going through that journey, I got into some of the top 5 business schools in the country. But when it was kind of time to take that leap, I said, I'm gonna lose 2 years of my time. I'm gonna be hundreds of thousands of dollars in debt, and then I'm gonna come out trying to do something else. Well, right around that time, I had the opportunity, and I met the right folks to start CipherCloud. And I'm like, what? I'm gonna do the real world MBA. And I'm going to start a company, and I'm going to learn on the fly. And I've just been fortunate just to be surrounded by great people, learn through experiences, learn through failures, learn through successes. And now, honestly, that's what just ticks my clock. Like, I love creating new products in new categories. And I guess what has happened, fortunately, last 2 times is we've timed it well. We've been at the right market, at the right place, with the right product. And hopefully we can do it for the 3rd time around here with Endor Labs. But, that's just the most exciting part and most fulfilling part, is solving a need that is here. And typically for me, we've been focused on mid to large enterprises. So, not the 1% companies of the world like Google and Facebook who can do a lot of this on their own, but the 99% that unfortunately don't have the resources and the budgets to kind of do all of this in-house, and really trying to help them get best-in-class products and capabilities.
Yeah, that makes sense. I think you've been able to time it, like you said, at right time, right place, in terms of the solution and the industry problem. Speaking of which, you're, in my opinion, focusing on one that is very timely, software supply chain security, which, I've been talking a lot about lately. So I wanted to ask you, now that you're focusing on this problem, prior to some of the others that you focused on, why is this one so complex, and why is it just now getting so much attention? Is it a new problem, or, it's just something that we're just starting to pay attention to?
Look, I'm going to go on a rant a little bit here, but software supply chain security, the terminology, unfortunately, has become pretty abused. It's become a catch-all term right now, which, if you look back in 2015, 2016, when we were starting Redlock, every company on the planet was claiming to have a cloud security product. And, these were traditional companies that were building traditional firewalls. These were traditional endpoint products, traditional vulnerability scanning products. And today, we have the same problem with software supply chain security. Let me articulate kind of what our belief is. Yes, software supply chain security is a catch-all. There's lots of things from kind of container image signing and security to dependency management to CI/CD security. But our belief is when 80 to 90% of your modern application code is code that you don't write, but you borrow from various parts of the internet, the foundation to software supply chain security begins with dependency management. And that's kind of, resulting from dozens of conversations we had when we were thinking about kind of starting Endor Labs, is that's where it was squarely in terms of the biggest pain point that customers have and the biggest unknown. And look, let me just draw an analogy here. Most large enterprises have fairly mature third-party risk management programs for commercial vendors, right? So like procurement won't even let you buy anything in an enterprise or in a government agency unless you have certain compliance regulations met, unless you have questionnaires up the wazoo filled out, unless you have pen test reports. That's the front door of your house. The side door of your house is developers every single day are bringing in new code from the internet written by strangers that we know nothing about. And that just kind of is shocking to me, that whole concept. And so, I think that's been clearly validated in the last year as we've been building Endor Labs. And that's why we have chosen to focus on dependency management first. We obviously have larger aspirations, but that's the foundation to Endor Labs.
Yeah, I love what you laid out there because, we hear all the talk about supply chain risk management. And as you mentioned, there's tons of questionnaires, SOC 2 and FedRAMP and all these kind of things. We hear a lot about zero trust, right? No implicit trust, but we have a lot of implicit trust when it comes to open source software dependencies that we're using at scale across our enterprise. So many organizations are struggling, as you said, with open source software governance. Why do you think it's such a challenge? And, how do you propose we go about addressing it?
Yeah, the interesting part, Chris, is and I'm going to say something controversial, but most organizations are not doing software development as much as they're doing software assembly today, right? Because the first thing an engineer does when a product manager gives them some requirements, especially with the time pressure, and rightly so, I'm not saying they're doing the wrong thing, is they're smart. Like smart engineers want to reuse whatever is possible as quickly as they can. And so they go look on the internet. Google is an engineer's best friend. They look at Stack Overflow. They look for articles on Hacker News. They'll look for stuff around GitHub. And they kind of bring in lots of different components and then begin the journey of assembly. And so, in that journey, unfortunately, we are not arming the software engineers with much context and data based on which they can make risk-driven decisions, right? Today, the way they make those decisions is, is it on GitHub? Okay, are there some stars? Are there some forks? Okay, let's start using it. You still don't know anything about the humans. You don't know anything about the motivations for these people. How well supported are these projects? What is the history of shipping software? How many, security problems have they created in the past? How many quality issues? How many API breaking changes have they shipped in the past? What is the health of the repository itself, right? Do they have CI in the process? Like, do they have good test coverage in the code? We just don't know a lot. And so, and frankly, developers don't have the time for that, which is why they're going to GitHub looking for the code in the first place. And so I think there's kind of these conflicting priorities. You're trying to focus and optimize for speed, which drives you towards open source. And there's not a lot of tooling and automation to help you make risk-based decisions today. And you don't have an army of people, frankly, that are going to go look at everybody's code and decide if you should use it or not. So that's one. Two, once you kind of bring in this code into your environment, you assemble it, you ship your feature, you kind of move on. Like, I haven't seen anybody's like on the OKRs for engineers being, you have to keep all the dependencies you bring in from the internet up to date. Like, it's not there. Like, typically, people will go back to update open source software when something breaks or when there's a security issue and they're being told to go break it. Like, they just don't have time to go continuously monitor that. If that was commercial software, there would be a customer success team from that software provider kind of hounding you, chasing you down to make updates, telling you when something is getting end of life. But that continuous monitoring isn't there for dependencies. The last piece I'll say is there's nobody whose job is being a dependency removal engineer in an enterprise, right? So lots of people bring in dependencies for solving their kind of tactical need. And then you move on, you forget about it. These dependencies keep stacking on. Your dependency graph becomes massive, but nobody's looking at optimizing it, removing the unused things. We're frankly pretty fearful of making changes to dependencies because you don't know what else will break. It's a bit of kind of turtles all the way up. So, this is really where we think technology can solve this problem. from selection of dependencies and good quality, healthy, secure dependencies to the security, the usage, and the maintenance of these libraries. So, it is really a life cycle problem that you need to solve.
Yeah, it's funny. Once again, you point out like kind of a traditional security edict that we all follow, which is, patch software right away as soon as a patch is available. When it comes to dependencies, if it's not from a proprietary software vendor, for example, we just don't do that best practice for some reason, or it's very hard to do it at scale, and you kind of touched on this, which is the term dependency hell that developers use when it comes to keeping dependencies up to date, watching for dependencies being end of life and so on. So, how do you propose as an industry we start approaching this? How are you guys approaching this? How do we help solve for this challenge?
Yeah, so, we're kind of the first product that we've launched is called Dependency Lifecycle Management platform. And really what it does is, first and foremost, we've shifted as far left as we possibly can. And we do that by giving developers insights on any package, any dependency that they're looking to download from the internet. And we look at dozens of different indicators of risk, right? From quality to security to activity to popularity, ultimately saying, what is the likelihood that if you bring this in, you're going to run into trouble? And that in the selection criteria, we think is the best point, because at this point, the developer's not married to this package or dependency, right? Like you have the opportunity to convince them to do something else, versus if you tell them this 6 months after they've kind of integrated this into their application, tested it, deployed it, that they screwed up, well, chances are they're going to be pretty defensive. So first and foremost, we really want to provide leading indicators of risk at the point of selection. So that's one. The second piece that, we're going to probably get into this point is when you think about security, on average, what we have found is a typical enterprise has about 40,000 direct dependencies. And if each one of those on average of the NPM ecosystem is bringing 77 indirect dependencies, you're sitting on a stack of millions of different dependencies. So just understanding how they're being used, what is connected to what else, what do you need to prioritize fixing is difficult. And unfortunately, all the existing tools for securing these dependencies, software composition analysis effectively, all work the same way, which is they scan your manifest file, they look at what are the things you're importing, not caring about how exactly your developers are using these, and ultimately give you every possible kind of vulnerability report out there. Now, the problem is the developer is guilty until proven innocent. So security teams say, here's a report from my favorite SCA tool, and it tells me you have 1,000 vulnerabilities. Here are 1,000 JIRA tickets. Now, the poor developer has to go through each one at a time, look at their code, and basically decide if that is something that is truly exploitable, truly impactful or not. And then has to come back to security and say, I looked at my code and I didn't do this. Now, who do you believe? Do you believe the tool? Do you believe the developer? It's a hard problem. And so fundamentally, the way we're solving this with Endor Labs is we are kind of automating this process. Instead of just relying on manifest files, we're actually doing static analysis of your entire dependency graph and looking at how your first-party code calls these dependencies, which APIs, which methods, which functions within these dependencies do you actually use and invoke in your code, and kind of what other dependencies does that call. And by doing so, we can remove 80 to 90% of the vulnerability noise that traditional SCA tools actually deliver to customers. And so by doing this, we're actually creating a very pragmatic program, right? So again, recap. First, we helped you select good quality dependencies, healthy dependencies. Of the things you brought in, we're actually very, very targeted on how you must secure them and actually prioritize what you need to fix and what you can actually defer. And with that same technology of building the call graphs, we can actually help you decide and best determine the update paths. Because the biggest fear engineers have with updating dependencies is, what will I break? And that's kind of foundationally the dependency hell problem, right, in development, which is, holy smokes, like this has a dependency on this, and if this is pinned to this particular version, if I change this 3 levels down, maybe somebody in another team in my company will get impacted. I just don't know. We're providing all of that visibility so developers can update with confidence all of their code. So that, in essence, Chris, is how we are striving to solve dependency hell problem. Uncover risks early, get the right healthy dependencies, secure them in a much more prioritized, targeted way, and give you all the insights to update and fix things. So when that next Log4j incident occurs, as the DHS report says, hopefully nobody will ever spend thousands of hours trying to figure out how are they impacted and where they're impacted.
Yeah, I love where you're going with all of this, because I'm following along the dialogue. Within the industry, like you'll often hear groups like Sonatype and others mention, like you did, upwards of 80% or 90% of code bases are open source software components, and they have vulnerabilities. But then you'll hear other people like Jeff Williams and so on, AppSec leaders say, yeah, but these these pieces of code aren't reachable, they aren't used. So you're kind of stringing together that thought process to get to actual enrichment and prioritization of vulnerabilities for developers, for example. And it reminds me a lot of what Snyk is trying to do in other ways, where they talk about like developer empowered, security. Essentially is what you're doing. You're shifting that context left, so developers can be empowered to make those decisions. So I like it a lot. Another thing I wanted to ask you about is, there's a lot of being said about software bill of materials and vulnerability exploitability exchange. I'm curious, from your perspective, focusing on this problem, of dependencies and so on in software, what role do you think S-BOMs will play in the kind of the push to secure software supply chains?
Look, Chris, a great question, right? I think ultimately, why is everybody mentioning S-BOM? A couple of things, right? S-BOM to me is a means to an end. Ultimately, everybody wants to have a conversation to say, do you have visibility into what are the components that go into your software? Do you have a process to govern all of that? And can you give us confidence that all of this works in your environment, right? Now, the way all of us have kind of centered around this conversation in the industry is following the S-BOM topic. Now, the problem is, as you know, it's great, but if you just are focused on creating an artifact called an S-BOM, it could go wrong in many different ways, right? So going back to this lifecycle management that we just discussed, ultimately, if you don't have a good process or intake process for new dependencies, and selection process, if you don't have a good process to manage those dependencies, update those dependencies, yes, you can have an easy button to create an S-BOM, but if somebody looked deeper into that S-BOM, they're going to come back to you, the producer of S-BOM, with hundreds of questions around, hey, why do you have this piece of software? Why aren't you doing something about this vulnerability, that vulnerability? So I think we need to think about S-BOM as not an artifact, but really a conversation around a broader topic of dependency management. The other part is, to your point, you mentioned VEX. I think it's funny because in 8 out of 10 conversations I have, and I have dozens of these conversations every week, as I'm sure you do, 8 out of 10 of those folks have never heard of VEX. And that is a problem in my mind. Because if you build S-BOMs, which is great, you're going to tell me every artifact, every dependency you use, and you do not provide a VEX to go alongside that, you're not only creating a ton of work for yourself, but you're creating a ton of back and forth with your potential customer or user of that software. And so it's really, really important that anybody talking about S-BOM understand VEX. And to me, an S-BOM without a VEX is useless, because what the VEX is telling somebody who's looking at the S-BOM is that, hey, of all of these things that I use, I already understand and recognize, and I am preemptively telling you that you may find running your scanner that we have these potential vulnerabilities, but we've looked at our code and we don't think that these apply to us for a variety of these reasons. This is why we will not be fixing them. And combined, you have the context. Without that context, you're kind of flying blind and just checking boxes for compliance, but not really solving the problem. So that's one. I think the second part is S-BOMs are great, but Chris, as you know, even for the organizations that are now standing up and saying, I'm going to require S-BOMs for my vendors, they have no idea what's about to hit them, because an S-BOM is only as good as at the point in time it was generated. And most software kind of updates are happening weekly, bi-weekly, monthly. And as an enterprise or an organization that's going to start requiring hundreds of vendors to provide S-BOMs, you're going to get bombarded by these documents. And when I ask people, what are you going to do with them? Some of them are filing them in SharePoint. Some of them are putting them in Google Drive today. There's no systemic way to manage all of this intake process. And I think that's a problem. And I think most organizations, in an ideal state, in our opinion, need to have a single platform that helps them create and manage S-BOMs for their custom applications, but also brings in all of the third-party application S-BOMs in an automated fashion, consolidates all of that software inventory for you, kind of risk ranks all of that information for you, and has a system of record, because next time Log4j happens, hopefully you're not calling every vendor or sending emails saying, do you use Log4j? Do you use Log4j? And it was just comical seeing kind of how that process was handled last time around. And I think we as an industry need to get better at it. Just like we've had ServiceNow now as an industry standard for IT asset management, you kind of need a software component level asset management system. And obviously at Endor Labs, we're striving to be that. But I think as an industry, we all need to come together and drive that message home.
Yeah, I think you're spot on. I think, as you said, like S-BOM will be a piece of the solution, but without an accompanying VEX, and especially like an automated, platform or solution to ingest these and make sense of these and take action on them at scale as appropriate, it's just going to be a lot of noise and a lot of back and forth, as you said. One thing I wanted to ask you too is you talked about a little bit about this earlier with dependency hell, and you talked about reaching code and the execution path and so on. Trying to get to the the context, the nuance of exploitability of vulnerabilities, for example. One thing I've been writing and talking about, and I think you're familiar with, is EPSS. Any thoughts on using that to accompany like CVE information or CVSS information, I should say, to provide even further, potential, insight into potential for exploitability, things like that to enrich that, CVE information further?
Yeah, great question, Chris. And I think there's kind of two sides to impact analysis and risk analysis, right? One is what we described through call graphs and execution paths, doing it statically, not requiring runtime agents, but doing it statically inside out to understand how is your code being used and what parts of the code path in your case are most impacted. From an outside-in perspective, obviously as an industry, we rely on CVSS score. I'm not going to get into that debate. There's lots of conversation you've written about why the flaws around that, right? And I think that makes total sense. I mean, this is decades old now. A refresh is much needed. And I think some of the vendors in the space have been trying to create their own versions of outside-in kind of exploitability scores and indexes, right? They're looking at dark web, social media conversations and saying, well, here's the likelihood that this particular CVE will actually be targeted. Well, the problem is if every vendor tries to does it themselves, you kind of ideally need a standard. And so I like what EPSS is doing because you have a prediction model which you can overlay and let customers decide what are the prioritization aspects through that model. The thing I don't like, and you've written about this recently, is just it's closed loop. Like people don't really understand what that algorithm does, right? And for something to become an industry standard, I think it's really important that people get more transparency, visibility into behind the scenes, like how does this thing really work? And people should be able to provide input and feedback and agree on the algorithm behind all of this. But that said, I think it's really good in the place where we are, where large enterprises have hundreds of thousands of open vulnerabilities that they have no idea how to prioritize, to give them the inside out ways to prioritize based on how their code is being used, as well as give them exploitability ways and allow them to kind of, in an ideal solution, pivot of kind of permutations and combinations of how they want to report and filter on this data. But certainly more transparency would be helpful.
Yeah, I think it's extremely ironic. At the same time, we're pushing for all this transparency around software component use. At the same time, we have these opaque models that we use to make decisions on what we do with these components in terms of remediation and vulnerability management and so on. So it's really interesting. So another thing I wanted to ask you, you used the term earlier, leading indicators of risk. And I know you actually recently wrote a piece citing some research from someone that I interviewed called Chinmayi Sharma, who wrote A Tragedy of Digital Commons, which is a great white paper. I recommend folks go check it out. It talks about the open source software ecosystem. I want to ask your thoughts about leading indicators of risk. I know you talked about, touching the code and execution path and things like that. Any thoughts around, looking at projects and things like that and components and seeing number of maintainers, national origin, mean time to remediation, other things to enrich your decision-making process?
Yeah, I think it's critical, Chris. So let's think about what we have done as an industry so far, right? Like let's even think about how SCA has evolved as a technology platform. It all started with license scanning, right? A decade ago, everybody was kind of concentrated around legal risk. Then those vendors said, okay, well, let's kind of add on this technology for vulnerability scanning. Well, what are vulnerabilities? Vulnerabilities are typically well-intentioned developers making accidental coding errors that ultimately surface or get discovered by some researcher or somebody, get logged in a database, and now your vulnerability scanning tools and SCA tools are surfacing that information to you. Vulnerability scanning tools and SCA tools actually, for the most part, do not uncover known malicious actors trying to compromise you through the open source ecosystem, right? Like those don't typically show up as CVEs. There are other sets of challenges, right? Typo squatting, dependency confusion, malware proliferation. And the analogy I'll draw here, Chris, is endpoint security, right? Like about a decade ago, everybody used signature-based AV. That was the gold standard for your desktops. And along came CrowdStrike and Carbon Black and a bunch of companies that said, well, that's not enough. You really need EDR because not only can signatures just always be bypassed, you need other indicators of risk, but you also need to think about detection and response when things go wrong. I think we're at the crossroads as an industry on open source where that shift is needed for open source security and governance, meaning vulnerabilities aren't going to catch anything. It's an important indicator of risk, but it's one dimension. And really what we need to do as an industry is start looking at broader dimensions of risk and ideally, as you said, leading indicators of risk. Now, what are the things that can kind of give you early feedback, and especially when I was talking about the selection process shifting left? Well, I'll give you some examples, right, now of things that we look at, and obviously OpenSSF Scorecard Project is a great initiative to do this as well, is things like you said, hey, like how many maintainers are behind this project? How active are they, right? What's their commit history? Did a maintainer change? Like, did a project become an orphan project because the maintainer has left, right? Is the email domain still valid on the maintainer, or could it be an easily hijacked project? Do they have test coverage on their code? Do they typically do code reviews when somebody from the internet pushes some contribution into the ecosystem? What is the typical mean time to resolution when people report issues? Lots of different ways to consider the health of the project, health of the community, and overall risk of what you're about to use. And I think that's critical. So getting those leading indicators of risk are critical. Prioritizing vulnerabilities is critical. And the third thing I think that's now becoming extremely important is looking at the code itself. Okay, so most SaaS programs, most static code analysis programs for an enterprise are fixed on first-party code, right? Like they're scanning their first-party code to look for vulnerabilities and exploits. Well, here, why wouldn't we, in the open source ecosystem, look to see if the code behavior is changing between releases, right? If something wasn't making strange outbound network calls, now it suddenly is. Would we like to know that? Would we like to understand those behavior patterns changing on the code base? And I think foundationally, like technologies aren't there to do it at scale. And that's another vector that I think really needs to be looked at more from a leading indicator of risk perspective to say, wait a minute, don't update. We see something that is potentially problematic. And, obviously a combination of manual intervention is required, but you need those signals first to be flagged by automation.
Yeah, that makes perfect sense. And I agree completely. I think that's another area that really needs a lot more attention as an industry. So I wanted to ask you a couple more questions as we wrap up here. It's hard to predict the future, of course, but you seem to have a good ability to kind of see where the industry is going and focus on that. So looking forward, say 24, 36 months, on the topic of software supply chain security, where do you see us as an industry when we look at things like dependency management, S-BOMs, VEX, and so on? Are we any better? Are we still got a lot of ways to go? Where do you think we'll be?
Look, Chris, cloud security, we started like 10, 12 years ago. And most companies, most enterprises will still put cloud security as their number one priority. So, these things take years and years and years to mature. My hope is in the next couple of years, if we can even just agree on the definitions and the framework of what these things are, that would be a win. Like, what is software supply chain security? Today, it means different things to different people. If we can kind of agree on the core components of this, we can understand on typically how an enterprise should tackle this. For example, one of the challenges I have looking at how things are evolving is there's a new open source tool a week, maybe 2 a week. You track this closely in software supply chain security. If I'm an enterprise user, it's overwhelming for me to even just think about how many things exist and where do I begin, right? So you almost need to create this easy roadmap for somebody in the enterprise to be able to adopt and understand, say, hey, this is step 1 for supply chain security. This is step 2, and this is step 3. Crawl, walk, run. I think if we can even agree on that framework, deliver that framework, that would be a win. I think if we can agree on how software bill of materials should be produced with confidence, with clarity, and how that information should be exchanged between organizations, and how that information should be consumed, right? VEX and everything else included in a more systemic way. I think that would be a win for the organizations. And last but not the least, I think everything in security, as you know, starts with visibility. If every enterprise could just begin with having visibility into their software supply chain, because you can't secure what you can't see, I think that would be a win. My goal, at least as an entrepreneur, as a founder in the space, is simply help educate enterprises on what needs to be done and give them the easy button to at least understand and quantify their risks so that they can start solving them over time.
Yeah, I think those are great predictions, and I honestly agree with all of them, and that's why I'm focusing on these topics myself so much. One thing I think worth mentioning that you touched on there is, the tool proliferation. We often talk about in cybersecurity a number of problems that we have to address and things like that, but we're having so many tools that teams are trying to use that it's causing a lot of cognitive overload on security teams themselves, just trying to address the challenges, the number of tools that they have to manage. So that's another good distinction and call out that you made. So I wanted to ask, I think you bring a really unique perspective as a security practitioner and now a business owner. As my friend Dr. Chase Cunningham put in the chat here, he said a degree from the School of Hard Knocks is more valuable than an Ivy League degree, which I think you've found. You found a lot of success in that route. So for folks looking to follow you, follow Endor Labs and what you guys are up to, where can they find you? Where can they find you guys?
Yeah, great. Look, we're pretty active on LinkedIn. Follow Endor Labs on LinkedIn. Our website is endorlabs.com. There's actually a lot of educational information. Just over the weekend, we launched a risk explorer on our website where people can actually visualize what are the different kind of attack vectors in open source beyond vulnerabilities. What are the things you need to kind of think about? So we will do our best to continue to educate the world with Chris, with friends like you, just helping people understand what the problem is. And, please follow us on LinkedIn. Please, watch out for our blogs. We'll be doing a lot more. And typically on our blogs, they're not written by marketing. They're actually written by engineers, by security researchers. We're fortunate to have hired some of the world's best people in this kind of domain around dependency management that are kind of world-renowned experts in the space. So you're going to hear a lot from them. So follow along and help us get the word out.
Yeah, definitely agree on that. The way you guys got on my radar actually was I do a lot of reading and research, and I came across your guys' blog, and I was like, oh, they actually know what they're talking about. It's not just marketing hype here. So, for definitely, folks tuning in, definitely check out their blog. That said, Varun, thanks for jumping on here and having a conversation with us, and thanks for everyone who listened in.
Yeah, Chris, really enjoyed it, and thanks everyone for listening.